Hello and welcome to Redgate University. My name is Brian McRae, pre-sales engineer here at Redgate. And in this class, I'll take you through how you can use Redgate SQL Compare and Redgate SQL Prompt to make sure that your database is ready for the continuous integration processes contained within Redgate SQL Change Automation. Now, continuous integration for the database is analogous to continuous integration at the application tier in that we need to recompile our code, we need to run tests to make sure that our application is prepared for deployment, for automated deployments. And it's no different for the database. We need to make sure that we can run the same level of rigorous testing. And so for this, we run what's called a database build. More specifically, the commandlet's called invoke database build. Now, within SQL Change Automation, you may be using it within the context of a DevOps pipeline system, meaning you're using one of our plugins that's associated with SQL Change Automation. But under the covers, these PowerShell commandlets are always the ones that are going to run, and you can't just write a PowerShell script to substitute for your database DevOps pipeline. Now, this invoke database build, this is the primary continuous integration commandlet. And the first thing it does is establishes a blank database for testing. Now, this is just a blank database, a temporary database used only for the purposes of this build. We then establish a comparison between our scripts that represent a blueprint of our database that are contained within source control, and establish a comparison between that and this blank temporary database. We then attempt to deploy the changes, basically trying to create this database from scratch. If we can do that, we assume that the scripts that we have in source control are appropriate and complete, and that the database is ready for further automation. Now, if I have any invalid permissions or orphaned users or other invalid objects, that will cause this build to fail because the corresponding object can't be created. That's what's happened here. I have a stored procedure, this PRC get contacts, that's referencing an invalid column. So let me go into SSMS and we'll take a look at this stored procedure. The SQL prompt is already going to go to work for me here and let me know with this red underline exactly where the offending column is. This description column doesn't exist in my database. So I'm going to remove that. We'll recompile and move this new stored procedure back into my version control repository. So there's the change. I've removed that description field from that procedure altogether. So I'll select that and move this into my version control repository. Once it gets moved over, I'll be able to return back to my invoke database build commandlet. We'll try that again and see if we can't get this database to build properly this time. So run that same commandlet, exact same process is going to execute. And you may have noticed there were a couple of different failures that will occur. One of the challenges that you'll have with this database build commandlet is that your invalid objects, the build failures that you'll see, will typically be captured in log files. It may not be immediately available or easy to see which invalid objects you may be dealing with. And so you may find yourself debugging the database kind of one error at a time and then going back through this process of trying to build again. I can see I've got another invalid object. This view that I have, this vArticles view, is also referencing an invalid column. Now, you can use some tooling within Redgate SQL Toolbelt to make this process a little bit easier. I can use Redgate SQL Compare and establish a comparison project between my development database or my version control repository. And in this case, I've just set up an empty database that I'm going to use to mimic the database that's created during the build process. And so I could also run a deployment. And so if I were to run a test deployment here, this deployment would mimic the process that the build command uses whenever it tries to run a deployment against that blank testing database. And so running this just using the comparison engine, kind of point and click, I can do it through the development IDE here. It's a little bit faster, a little bit quicker to understand exactly what might be occurring. But I'm still only seeing one incident at a time. If I wanted to get an overall view of my database, I could use a feature within SQL Prompt called Find Invalid Objects. Find Invalid Objects will scan the entire database, looking for objects like these, objects that can't, for whatever reason, be created. Now I can see I've got several views. I've got 3 different views that all have the same problem. And so I can remediate these kind of one by one, having this more holistic view of the total database. Now I can also use SQL Compare to help me shape and refine the information that goes from the database into version control by using filters. And so SQL compare filters allow you to exclude either classes of objects or objects by name or by a set of wildcard names. And so if I wanted to approach these views and filter them out, I could use the wildcard searches to filter these views out by name or by a sequence of names. But in this case, I'm just going to remove the entire class of views altogether because I don't really need them in my higher environments. And so you can see right now I've got 26 objects in the database. If I remove the views, I'm down to 21. And so now I'm going to try this deployment again. I have repaired the store procedure, and now that I am removing the views from consideration altogether, I should be able to deploy this database and deploy these changes in total. And so the comparison deployment is going to construct this patch script from the differences that it sees, and I can see that it was able to move these changes over into my blank database. And so using SQL prompts invalid object search, I've gotten a much better feel of all the invalid objects that might exist in my database. And then using compare filters, I can refine this process to filter out objects that I may not want to see or may not want to use downstream. Now, this filter can be used by the invoke database build commandlet as well. All you need to do is just create a path to it, and I have this filter called views.spf that represents the filter that I just built before. And so I'll run this build now with the updated change to the store procedure in version control, and this filter actually filtering out all the views from consideration. I know using SQL compare and the tests that I've constructed there that the deployment was able to run successfully. And so it's a fair bet that the deployment will also run successfully here within this invoke database build commandlet. And so once again, this does represent a continuous integration step. We are just using a temporary database, so this would be a part of the continuous integration process. And I can see that in this case, this build did complete, and so I can move on down the road. What happens as a result of this completion is the invoke database build commandlet will construct a NuGet package artifact, packaging up the information from source control and passing it along to your release mechanism. And so once again, I was able to show you how you can use Redgate SQL Prompt and Redgate SQL Compare to ensure that your database is ready for the automated continuous integration processes contained within Redgate SQL Change Automation. Once again, my name is Brian McRae, pre-sales engineer here at Redgate Software. I look forward to working with you guys again real soon. Take care.